Welcome to Calculus 1. Today we're gonna review a little bit on what we so-called the domain and range of a function. In the previous recording we talked about domain and range a little bit. Here I'm gonna just kind of rephrase it a little bit. What is so-called a domain of a function is referring to a set of all x values which the function exists in a certain interval. Okay, and I mentioned before that domain is referring to the x values, the range is referring to the y values. So the range of a function is a set of all y values that a function exists in a certain interval. In other words, when we look at a graph, domain is regarding to how wide the function is. You can look at it that way. Range is about how tall the function is. Okay, how tall a graph is. Alright. Now the best way to find domain and range is to actually graph the function, because different types of function has its own little quirk when it comes to finding domain and range. So the best way is actually graphing it. So for example, if I want to find the domain of this radical function, f of x equal to square root of x minus 4. Alright, let us graph it. This is a radical function, and the radical function normally looks like this way, but we can graph it and check. So second square root x minus 4, and we graph it, and the graph look like that. So let me capture it. Alright, so the function is keep on going to the right regarding to in terms of a domain. So my functions keep on going to the right side, and it will actually start at this point. And a lot of times to find the starting point, what I can do is set what's inside my function. Okay, what's inside the square root here, set it equal to 0 to find the starting point, and then so x will be equal to 4. So that tell me this function, okay, from left to the right, it started at x equal to 4 and keep on going to the right. So at the same time the function is going to the right, the function is also going upward at the same time. So if we go to the table, okay, everything before positive 4 for x is error. It does not, function does not exist there. So as x keep on going to the right, that means x keep on getting bigger and bigger and bigger. My y value is also getting bigger and bigger and bigger. So that means the x value is going to the right, the y value is going upward. So my domain for this function got to be from 4 using a bracket, keep on going to the right to infinity. Alright, let's look at another example of a rational function. Okay, this is a rational function. Alright, since this is a rational function, the denominator cannot be equal to 0 because the function is undefined. Okay, if the denominator is 0, the function will be undefined. So let us go ahead and figure out what x cannot be. In other words, what value of x will make my denominator equal to 0. So we say x squared plus x minus 56 cannot equal to 0. So I'm solving a quadratic equation. So if I will factor this, 56, 7 times 8. So x and x, 7 and 8. To get a positive 1 in the middle, I will need positive 8 and a negative 7 in the inner. Okay, alter positive 8, inner negative 7. So set each factor equal to 0, cannot equal to 0. That means my x cannot equal to 7. My the other x cannot equal to negative 8. So at the same time, you probably recall that these two numbers, 7, -8, will also be my vertical asymptote as well. Rational function has vertical asymptote, okay, where my function does not exist. Besides having vertical asymptote, sometimes a function can have a hole as well. Function does not exist there because there's a hole there. So here we establish what the true value x cannot be. So let's graph this function so we know what it looked like. 4 is one term, so I just type in 4 divided by. Denominator is 3 terms, put all of them in the parenthesis. So that will be x squared plus x minus 56, close parenthesis. Alright, my function look like this. Alright, so we talk about vertical asymptote. For my calculator, I cannot see the vertical asymptote because function doesn't exist there. So let me kind of draw it right here. So right here, there's a vertical asymptote at x equal to, it's too hard, it's too thick. Let me make my graph a little bit bigger. Let me color code this in red. So there's a vertical asymptote at x equal to -8. Right there. Maybe right there. Yeah, right there, that was good. And then another one at x equal to 7. Alright, those two are my vertical asymptotes. So my function does not exist, okay, at those two values. So if you actually look at the graph, this sides keep on going that way to the left, okay, and from -8 to 7, my function is over here. Let me use a blue, kind of like use a blue. So my function is right here. My function is, oh sorry, didn't mean to touch it. Can't touch it. My function is right here. Can't touch the vertical asymptote because the function does not exist there. And I got one over here. So as far as looking at domain, this side keep on going left, this side keep on going right. And I got two vertical asymptotes kind of interrupting my whole function. So my domain got to be from -infinity using parentheses, comma, all the way to my x equal to -8. Union, my function existed between the two vertical asymptotes. So that will be between -8 to 7. Union, it will also be from +7, keep on going to infinity. Now if I want to check it to make sure, I can go to my table and say, okay, let's go to a little bit to the left of -8. So my function exists, okay, to the left of -8. Once it reaches -8, it gives me an error. And my function exists between -8 all the way to +7, and it gives me an error, and it keep on going to the right from 7 and beyond. Alright, so that will be my domain. So we will talk more about rational functions and what it means when this side going up, this side going down, down, going up. They all got something to do with calculus. Alright, that will conclude this